Welcome back to the second video of determinants, or in this case the third video, but the second example video on determinants. And as I mentioned before, we're going to be working with a 3x3 and a 4x4 matrix. And so we're going to go ahead and do this example, and we're going to do it in different ways, so we don't have to use different matrices and then trying to check if this is actually the right answer. We could just do one and then do it in different ways and see that it still gives you the same answer. So for the first one, we're going to work on the 3x3 matrix. And so it wants us to calculate the determinant of this 3x3 matrix and also this 4x4, but we're going to focus on the 3x3 first. It's going to be 3x3 with 1, 2, 8, 3, 4, 0, and 6, 2, 1. So for this example, we're going to use what it's called the general way of solving any matrix. So it's going to be by method of square reduction. And as I mentioned briefly in the lecture part, it basically means putting or finding the determinant of a smaller matrix within the matrix. And so the way we do this, 1, 3, 6, 2, 4, 2, 8, 0, 1. So the way we do this, there's many ways to do it. The most general, or I guess the most common way to do it is literally doing it with first row. But as you go and do more of these, you can see that there's going to be some situations where instead of doing it from the first row, we can do it from, in this case, the third column, because there's a 0. And you're going to see what I mean by that. So the way we do square reduction, what we have to do is pick a row or column. It can also be a diagonal. I wouldn't really recommend that. I haven't really done a diagonal, but it in some cases a diagonal might be the most or the easier way to do it, because there might be a 0 here and a 0 here. In this case, it's not. But we pick a row, and I'm gonna do this twice. So for the first one is we're gonna do the first row. And then the other one, we're going to do the third column. So if we pick a row, and then to find its determinant is you pick, or not you pick, you get the first element that you come across by. So in this case, it will be in the first column. So, and then you multiply it by the determinant of a 2x2. Since this is a 3x3, we're going to find the determinant of a 2x2. So you're always going to find the determinant of one less of the original square matrix. So if this was a 4x4, we could just, when we do this, it would just be 3 times the determinant of a 3x3. And so to find this determinant of a 2x2, because there's many 2x2 matrix or matrices you can create here, but the one that we're gonna do is the 4, 0, 2, 1, and the reason is because we have the first row and it's the first column that we're gonna multiply with. That means is we're gonna completely disregard everything in the first column, and whatever's left over. So the first column and first row are just going to be completely ignored, and whatever's left over is going to take the determinant of that remaining element. And so if we were to do it on the 4x4, so we're going to do 3. We're still going to do first row. We're just going to completely ignore the first column. So this is going to be 3 times, and then the first row is completely ignored. So we have this matrix here. So you'll take the determinant of this 3x3 matrix. So that's how you, and so this is what I mean when you do square reduction. And we're not done here. We're gonna continue on the row or column that we picked. In this case, it'll be the row, and we're gonna add. So we're gonna move on to the next element, which in this case will be 2. Well, actually, we're not gonna add. We're gonna add it, but we'll talk about the signs later. So it's gonna be 2, and then again, we are I'm gonna use a different color. Completely ignore everything below the 2, and we're left with 3, 0, 6, 1. So we're gonna take the determinant of 3, 0, 6, 1. So we're gonna write them as we see them. So we're not gonna move the 3, 6, 0, 1. We're just gonna read it from like left to right and then from top to bottom. So it'll be 3, 0, 6, 1. And then lastly, our last column, or I guess the last element, would be 8. And then we're just gonna completely ignore everything below 8. And then we're left with 3, 4, 6, 2. So 3, 4, 6, 2. And that's it. So what we're gonna do now is we're either gonna subtract them or add them. But how do we know whether to add or subtract them? So the way it works is if you had any matrix, it doesn't matter what dimension, the order is still going to be the same. The only difference is it's just going to add a little bit more. So for the 3 by 3, what ends up happening is the first element, I guess the row 1, column 1, that'll be positive. And then going from left to right, it's going to be negative, positive, and then it's just going to be alternating like that. And then right here on the second row, now it's gonna flip. So instead of being positive, it's gonna be negative, and then positive, then negative, and it's gonna go like that. So all of that is gonna be alternating as you go down the row and down the column. So in the case of a 3 by 3, we have a positive, so it's gonna be positive 1, and then over here it's gonna be a negative, and then the last one is gonna be a positive. And when you add all those up, you will get the answer. So we're going to just do that real quick. So it's going to be 1 times, well, 1 times anything, it's just going to be 1. So we're just going to ignore the 1. And then the determinant of a 2 by 2, which if you recall how to solve it, it's just multiplying and then subtracting. So it'll be 4 times 1, which is 4, minus 0, and then minus twice. 3 times 1 is just 3 minus, again, 0. And then plus 8 times 3 times 2 is 6. Minus 6 times 4 is 24. And then what we get is 4 minus 2 times 3 is 6. And then plus 8 times 6 minus 24, that is negative 18. And so that is equal to... I don't know, I can't math. 4 minus 6 is negative 2 minus 4, 8, negative 146. And that is our answer. Let me actually double check this. This should be right. Granted, I am not the best with arithmetic. There is, or like I mentioned, like in the very, very beginning, as you go further up the difficulty in mathematics, you'll forget to do basic arithmetic. So let me double check. So 6 minus 24. Whoops. times 8 is negative 144 minus 2. Yeah. Okay, cool. So yeah, this is right. Assuming I typed it right. But yeah, this is right. And then now we're just going to go ahead and do it the other method. So the other method is the one I'm pretty sure it has a different name, but I call it expansion. And so what you do is you just take the original matrix. So we're just gonna go ahead and rewrite it. 1 3 6 2 4 2 8 0 1. And then what we're gonna do now is we're gonna expand it by copying the first and second column. So 1 3 6 2 4 2. And then what we're gonna do is we're gonna multiply the diagonals and then we're gonna subtract it from the diagonals that's going from right to left, or left to right, or from top to bottom, and then from bottom to top. And so what I mean by that is the determinant, this is going to be equal to, so 1 times 4 times 1, it would just be 4, and then we're going to add them all up, and then it's going to be 2 times 0. Well, after that we know it's going to be 0. And then lastly, we're going to multiply 8, 3, and 2. So 3 times 2 is 6 times 8. What's 8 times 6? 48. And then we are going to subtract the other set of diagonals that we're going to add up. So the first one is going to be 6, 4, 8. So it'll be 6 times 4. That'll be 24, right? Yeah, 6 times 4 is 24, and then you multiply by 8, and that'll be 192. Plus, we have another 0, so that's just gonna be 0. And then finally, I think red, it's gonna be 1 times 3 times 2, which is just 6. So when we do this, you know you did it right if the 3 and the 4 were not used, because like I mentioned, it's just diagonals. So we take the first set of diagonals, add them all together. Let me choose actually a different color. And then we subtract it by the, that's a terrible line, by the other set of diagonals that are added together. And this is what I mean by expansion, because you're expanding the matrix to be a non-square. And then we just add them all together and subtract it. So 4 plus 48 is 52. And then minus 196, or 192 plus 6 is 198. And so that should give us 146. Don't forget the negative. And as you can see, it's the same answer that we got. So these are the two ways you can solve a 3x3 matrix. Remember, expansion only works for a 3x3 matrix. Anything above or below it will not work. So this is only for 3x3, and then the square reduction, that is for any n by n matrix. So I'm gonna go ahead and stop here. This took a little bit longer than expected, But that means we can do this one, this last one, or should be relatively short if I don't decide to do anything else with it. But with this one, we can do the block method, and I will tell you why we can do it and what we need to do to check to see if we can do it. So yeah, I'll see you guys in the next video.